So I'm going to talk a bit about HAProxy, the history behind our infrastructure changes at Trouva, and why we decided to use HAProxy, what are the pros of using HAProxy, and what are the cons of using other choices. So a little bit about the history of Trouva and what Trouva is. Trouva is an e-commerce platform for independent retailers. Our goal since we started in 2013 was to always bring truly unique products to the hands of everyone across the world. And Trouva was originally named Streethub when we launched in 2013. Our goal was to prove that we can take the local supply and fulfill local demand. So initially our tech stack was basically an absolute minimum viable product. It was just GoDaddy hosting with static HTML files. So to kind of help you visualize that, this is how it all started, how it all looked in the beginning. So users would basically request static HTML files with boutiques in their area. So if I was looking for a boutique in Shoreditch, I would go online, I would find shoreditch.html, download it, and I would find any boutique that I wanted to go to. But essentially, after that, in 2014, we decided that we still want to meet the local demand with local supply, but we wanted to enable customers to place orders online. And this is where we kind of decided, okay, obviously you need something. Are we going to go down the path of server-side rendering for everything with just, I don't know, PHP or whatever was popular at the time? We decided to use, basically, build our own Node.js app, which was going to be hosted on Node.jitsu, which closed down, hence the rest in progress, RIP. And then we also decided that we're going to store all of our products and boutiques on Elasticsearch. And our single page app was at the time hosted on S3. And this is basically, again, just to help you visualize it, we just had our single page app, Elasticsearch, Node.jitsu API. So this is where kind of small problems started coming to play, because our front end was being served through domain A, and our Elasticsearch and Node.jitsu were on domain B. So what comes with that? CORS comes into play. So I'm not sure how many of you are familiar with CORS, but I imagine most of you are. But basically what CORS is basically a request mechanism in which every time that you want to make an API call from domain A to domain B, or even a subdomain A to subdomain B, you essentially have to say, okay, my server only responds back to these client apps. So you first do your pre-flight API call, which is an options request. And the server says, yep, you've got access, and then responds back with, yes, you have access on the options request. And then you have to do another API call. The client handles that automatically, but the client does another API call, which is your actual API call. So if you wanted to get a boutique, it would have to do the options first, and then the get boutique to find the boutique. And then finally, the server responds back with the actual data. So this was fine, because if you think about it, we only had 2 backend services, so configuring that was very easy. It was also easy on the client side as well. So in early 2015, we decided that we really want to focus on delivering great products. And the only way that we wanted to do that and expand it globally, not just locally within the UK, was to focus on the quality of the curation and start shipping internationally, rather than just focusing on the local liquidity. So what we decided to do is we decided, okay, we're going to rebrand Streethub and create this new brand called Trouva. And in order to meet all of the criteria that we wanted to meet, we basically decided we're going to create 4 single-page apps. One of them is Trouva.com, which is where you can buy products, where you can add products to your basket. The other one is the checkout process, which is we decided to split out from the main app so we can help the customers focus on the user journey of checking out, and just remove any of the distractions of the main site. And then we also created 2 other single-page apps, which is our own internal CMS and a retailer CMS, which is what the retailers use to manage their inventory, accept new orders, or reject them if they don't have them in stock. We still kept our core API, which was built in Node.js, but we moved it over to Heroku since Node.js closed down. And again, similar to before, we still kept Elasticsearch and for the products and boutiques. So this is what it looked like at the time. We had our 4 single-page apps. We had 1 JavaScript API and our Elasticsearch instance. So that meant that adding 3 new single-page apps meant that we had to go back on our backend services and update the course configuration to support all 4 single-page apps. Easy to do, but then as you start to think about it more and more, the more backend services you add, the more front-end services you add, there's more configuration piled on top and on top and on top. So it just gets a bit tedious to update. In 2016, basically this is our current state now. Since 2016, we have built 5 new services which work alongside the core API to deliver all of the content that the single-page apps need. We kept all 4 single-page apps, and we also introduced Algolia into the mix for doing the searching of products and boutiques. So to visualize that, again, we essentially have, I couldn't fit all of the services, so there's more services there. But this essentially meant that we had to, again, for every backend service, we had to go back, add all of the course configuration again. And it became so common for us to think about this thing that we were actually thinking at a point to create an NPM library which has all of the course configurations so we can share it across all of the single-page apps, which sounds a bit funny, but actually it was a common problem for us. And if you think about it, also, course doesn't make sense in the sense of basically you take almost twice the time to actually execute an API call. So that's where we kind of sat down and thought about things, and we decided to start routing all of the API calls through one single routing layer. So we started using HAProxy, and HAProxy sits between the user, every single user basically that's using our apps, and then and the other side of the things are basically single-page apps and all of our APIs. So what is HAProxy and why we use it? HAProxy is a fast and very efficient load balancer and routing layer. So why we use HAProxy? HAProxy helps us avoid CORS because we can route everything through a single domain. So if you're on checkout, you can do the request on checkout and you can still route to the same API service. If we're on, I don't know, Trouva.com, then we use that domain to access our API calls. At the time, we were also thinking like the other way of doing things would be to use, sorry, that sounded annoying. So the other way that we're thinking of doing things is basically use a CDN like CloudFront, so you can serve all of your single-page apps, and also define rules in CloudFront where you can basically route all of the APIs. But we decided we didn't want to go down that path because that meant that we had to do caching validation on the index.html. And although that's a very reliable thing to do, it also takes time. And sometimes you're not entirely sure how much time it's going to take on each different edge node across the world. So I'll show you in a bit how we use HAProxy to get around that problem. But for now, keep that in mind. And the other reason why we decided to use HAProxy is because we have one single routing layer. So all of our requests go through one single routing layer, so it's easier for us to debug things. It's easier to go back and look at the history because you have one log. It's just, everything's a lot easier. And also HAProxy comes with a very interesting and excellent statistics dashboard. So there's one statistics dashboard that you can go to and you can see how many requests are failing per second, how many requests have passed, how many requests are going to every different service, or how many times you have served your single page app. So just to talk a little bit about how we actually do the redirection. You kind of, before you actually start implementing things, you need to start thinking about how you're going to basically, this is where namespacing comes into play. So if you start namespacing things, so if I want to start accessing the list service, what we decided to do is we can namespace everything under /API/lists. And then for the inventory service, it's /API/inventory, similar with a cart. And then for anything else that doesn't match those rules, we're basically going to route everything to our core API service. So how does the configuration actually look like? HAProxy has three concepts which are quite important. They have the concept of a front end, which is essentially it's essentially one input. So think of the front end as basically where the request is coming from, and then think of the back end as where the request is going to lead to. So if you think of a routing layer or just like any standard like routing, think of the input as being the front end and the output as being the back end. And you can actually name things, and you can have multiple different front ends and multiple different back ends. So here, for example, we decided to name this specific front end, we decided to call it HTTP-in, and it listens on the port 4040. And then we can set up a load balancer in front of it so that we can have everything on port 80. And that allows us to have multiple HAProxy instances behind one load balancer. The third concept that HAProxy has is the concept of ACLs. ACLs are access control lists. And basically, that is very similar to saying const something equals something. So it's just a variable. And what you actually, basically how this works is you say access control list is HTTPS. That's the name of the variable. This is my condition. So I want to say, I want you to look at the header X forwarded proto, and I want you to check if it matches that value. So here we're checking if the request that's coming in is an HTTPS request. Then we've got two more access control lists. One checks if the path begins with /API. So if that matches, then basically his API will be true, so we want to route to the core API. If the path starts with /API/cart, then we need to route to the cart service. And then we use the use backend directive, which essentially takes the first thing is the backend that we want to redirect to, and then our condition. So if this is not HTTPS request, then I want you to use that backend. And anything after that is not going to be called because we're going to be using that backend. So for the HTTPS redirect backend, that's quite simple. We basically use the redirect directive, and we say redirect scheme HTTPS code 301 basically means that I want you to change the scheme of this request to HTTPS, and I want you to do a 301 redirect because we always want to be using HTTPS. If we want to proxy the request to our core API, HAProxy allows you to have multiple different servers. So it will check that because it's a load balancer, you can have like 3 different instances of our core API, and then it will know how to distribute that load equivalently. So basically you say, my first server has that name, and that name is going to be used in the statistics dashboard. I want you to route to that IP on that port. So 443 is our SSL port, our HTTPS port. And I want you to verify that this request has an SSL because we always want to make sure that there is an SSL associated to that request. And I want you to, the check directive, basically all it does is it checks that the server is up and running before doing the routing. So there we have 2 servers, and then HAProxy automatically knows, hey, I should load balance this, and then I should do 50-50 traffic. So that's quite handy. So I talked a little bit about the API proxying, but what about like the client routing? Because I mentioned earlier that we also route basically all of the index.html files. So the way that we do that is instead of looking at the actual path, we also look at the domain or subdomain, whatever. So if this is a www subdomain or just a naked domain, then I want you to route to the Trouva.com website. If this is a checkout, retail, or our internal CMS, then I want you to route to the appropriate location. And to show you an example of that, of how how we serve our Ember apps is basically this is the example. Again, we've got a front end which is named HTTPN. It's listening on port 4040. And we first want to check which, not API, which client is this. That should have said. So we're checking if that's the, if this is our checkout. So if the request coming in matches the secure.trouva.com, so if the host is, if the beginning of the host is secure.trouva.com, then assign basically the result of that into the is checkout. And then use backend checkout if it's checkout. Now, obviously, you wouldn't do this for just one single domain. You would do this for multiple. So we've got our 4 single page apps. So we have more of these. But just to fit everything on the slide, I trimmed it down. So then our backend here is called checkout, and we want to do 2 things. We either want to serve the robots.txt if they are trying to access the robots.txt, or we just want to serve our main checkout app. So you can have multiple ACLs inside a backend. So we're creating here an ACL which checks if the path of the request is going into for the robots.txt. If that is true, then what it's going to do here, it's going to set the path of the resulting request to our S3 bucket, and then the specific path to access the robots.txt, and only do this if robots is true. And then the other way around is basically if it's not any of those, then we need to serve our index.html file. So similar to that, we say set path to the S3 buckets, the path of the index.html file, unless robots, so the other way around of if robots. And then S3 actually expects that the request that's coming in will have the header of host to be the S3 bucket. So we actually get around that problem by setting the ending request as basically we're marking the host to be what S3 is expecting. So then finally we say server. The name of the server is called checkout, and we say the public S3 subdomain of AWS. So basically what HAProxy is going to do is going to take the domain that you've given there. It's going to update the host header to the Amazon AWS one. And then it's also going to set the path to any of these 2, depending on what you're trying to access. So basically, as a summary, why we decided to use HAProxy is mainly to shorten the request lifecycle, because it's very important as an e-commerce business to have things really quick. We also wanted to avoid cache invalidation by getting around basically CloudFront and just using HAProxy to serve the index.html. I mean, everything else, all of the assets go through CloudFront, so all of that is cached. And it's also easier for us, again, to have one single routing layer to go back to. If something goes wrong, we can check one log. We can see one stats dashboard, which has everything in, all of our backends, all of our front ends. And yeah, so that's it. Thank you.